Hello everyone. Here the question is Ravi starts for his school from his house on his cycle at 8:20 a.m. If he runs his cycle at a speed of 10 km per hour, he reaches his school 8 minutes later. And if he drives a cycle at a speed of 16 km per hour, he reaches his school 10 minutes early. Then at what time the school starts? This is what our question. So a boy is moving in a cycle. When he is moving with a speed of 10 km, he is going late to the school. When he is driving that with a 16 kilometer per hour, then he is reaching schools little earlier. This is what the data they have given. So we can solve this problem in two ways. One, we can use speed equal to distance by time formula, and we can find this t, and from that we can find what time the school starts at. And the second one, we are going to use the proportion concept, because here they have used two words, right? That means keywords. One is speed and what is the time. So we can even use the proportion concept. So the speed equal to distance by time concept we can use. I told now that's a little lengthy method, and I have already uploaded a video for the same question using the speed concept, which is distance by time formula I have used. So I have given the video link in the description, so please refer to it. But now in this video, we are going to solve the same question using the concept of proportion. Let's look into the question now. So yeah, now we have speed as well as time. These are the two keywords given in the question. Initially, the boy is moving with 10 kilometer per hour. He reaches the school 8 minutes late. Usually he will reach the school by t, but now he reached 8 minutes late, plus extra 8 minutes has been taken. So t plus 8 minutes. Now what is the second case? 16 kilometer per hour he is riding his cycle, so that he is reaching a school 10 minutes earlier. It means what? As usual time is t, but before 10 minutes only he reached the school. So I can write it as t minus 10 minutes. So this is what the first data we need to know. And now we are going to find the relation between the speed and time. Then only we can decide whether this is a direct proportion or indirect proportion. So what is the speed has been increased, right? From 10 to 16, the speed has been increased. If the speed increased, what about the time? Initially, extra 8 minutes has been taken, but now the time has been reduced. So when the speed increased, the time got reduced. Then what proportion is this? It's an indirect proportion. So we are going to proceed with that indirect proportion concept. But before that, see here, the time is in hour. Why it is in hour? Because the speed is given in kilometer per hour, so obviously the time also need to be in hour. But here they have given 8 minute and 10 minute, so we have to convert this 8 minute and 10 minute to hour, then only we can proceed with this problem. First let's do that one. So for the first case, I am going to find the t in r, total t. So here it is in 8 minutes, right? 1 minute is 1 by 60 r. So 8 minute is 8 by 60 r. So what will be the time for the first case? T plus 8 by 60 r. Then we can cancel this 8 and 60. So it will go in 4 tables. So 4 twos are 8 and this is going to be 15. So t plus 2 by 15. And again, if you take an LCM, you will be getting 15t plus 2 divided by 15. This is what we will be getting over here. Now for the second case, it is t minus 10 minutes. So you know what is 10 minutes, right? In hour, it's nothing but 10 by 60 hour. Because 1 minute equal to 1 by 60 hours. So 10 minute equal to 10 by 60 hours. So here only we can cancel 0 and 0. So the time duration, if we simplify as a single fraction, it is going to be t minus 1 by 6. Then we have to take an LCM, so that it is going to be 6t minus 1 by 6. So now our time is like this, you have to take. So for 10 kilometer per hour, what is the time has been taken? 15t plus 2 divided by 15 hour. And for 16 kilometer per hour, the time taken is 6t minus 1 by 6 hour. So now we have found it's of indirect variation, right? So we are going to apply that. So in indirect variation, you are going to write any one fraction in the reciprocal manner. So I am writing here 10 by 16 as such, and here the time I am going to do in reciprocal. So for 16 kilometer per hour, time I am going to write in the numerator, and the time duration for this is 6, and the time duration for 10 kilometer per hour I am going to write in the denominator. Hope you know what is indirect variation. Yes, so the same thing we are going to apply over here. Yes, so now we are going to solve these things. Yeah, first I can solve this 10 and 16. It may go in two tables, so it is 2 5s are, and this is going to be 2 8s are. And here 6 and 15 also will go in three table, so I can solve this 3 2s are, and this is going to be 5s are. So now we are going to continue. Yes, now our LHS getting 5 by 8, it is becoming, and now our RHS is 60 minus 1 by 2, and we can take a reciprocal of this denominator, right? That means the denominator fraction. So I'm going to change this division into multiplication by doing the reciprocal of this fraction, 5 by 15t plus 2. So now we are going to solve this one. Yes, and here I can write this as 5 by 2 and the numerator as 60 minus 1 divided by 15t plus 2. Why I have splitted this constant fraction separate means I can move this 5 by 2 to the LHS, right? So that is what we are going to do. So 5 by 8 already there in LHS. Now 5 by 2 is going to move from RHS to LHS. So it's going to be of reciprocal 2 by 5, which is equal to what we have. It is 6t minus 1 divided by 15t plus 2. So now here on the LHS we can cancel 2 one time, and this is for 4 time. Now 5 and 5 will be getting cancelled. So now the leftover linear equation is what means on our LHS it is 1 by 4, and on RHS it is 6t minus 1 divided by 15t plus 2. So we are going to solve this linear equation and find what is the value of t. So let's do that first. So we are going to solve this linear equation by cross multiplication method, so that this 15t plus 2 going to move to the LHS and this 4 is going to move to the RHS. So we'll do it. 1 into anything is going to be the same. So I'm writing directly 15t plus 2 is equal to 4 into 6t minus 1. So 15t plus 2 equal to 24t minus 4. So we need to solve. So I'm keeping all the constant on the LHS and all the t variables to the RHS. So if I solve it, on the LHS will get 6, on the RHS 24 minus 15 is going to be 90. Then what is actually t value? T value is 6 by 9. So still 3 is a common factor. So we are going to cancel with the 3, so that it's going to become 2 by 3 hour. So what is the time duration? It is taken to move from home to school. It's 2 by 3 hour. So still here our question has not arrived with an answer. So here home and here school. So boy starts at 8:20 a.m. So to reach the school, it will take how much hour? It is 2 by 3 hour of time has been taken. So we need to add this time to this 8:20, so that we will get the starting time of the school. For that, first we need to convert this hour to minutes, because we don't know 2 by 3 hour means how many minutes. So we are first converting that to a minute. 1 hour is 60 minutes. Then 2 by 3 hour is going to be 2 by 3 into 60. So if we cancel it, we will get 40 minutes. So 40 minutes of time is taken for moving from home to school, right? So yeah, so we are going to add with 8:20 40 minutes. Yes, so if we add, it is going to be 60, and here it is going to be 8. So what is this? 60 minute is nothing but what? 1 hour. So I'm going to make the 60 as 00, and 1 is going to be added over here. So we are getting the answer as 9 a.m. So this is the time the school starts at. Hope you understood. Thank you.